Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1, and today we would like to do a presentation about problem-based learning, semester 2, season 2025-2026, Algebra and Calculus. First of all, I would like to introduce myself. My name is Nopana binti Al-Fazli, matrix number AA250891, and today the presentation is about differentiation is used to solve many engineering problems involving rate of change and maximum or minimum values. These reports discuss two problems: water draining from a conical tank and bridge cable tension optimization. For the problem background, the first problem is related to rates. The first question used related rates to find how fast the water volume decreases as water drains from a conical tank. By relating the changing water depth to the changing volume, we can determine the rate of volume loss at any given moment. For problem 2 is optimization. The second question used differentiation to find the maximum force on the bridge cable. By finding the stationary point of the force function and applying the second derivative test, we can confirm the maximum volume.
Hi, my name is Zayani binti Zulkifli. Matrix number AA251945. Next, we will discuss the related rates problem involving water journey from a conical tank. The tank has a height of 6 meters and a radius of 3 meters. At a certain moment, the water depth is 4 meters and the water level is decreasing at a rate of 0.2 meters per minute. To solve this problem, we first use the concept of similar triangle relationship. Since the shape of the water surface remains similar to the shape of the tank, the ratio between radius and height is constant. Therefore, R divided by H equals to 6 divided by 6. Simplifying gives us R equals H over 2. Next, we use the cone volume formula, which is 1/3 pi R square H. Substituting R equals H over 2 into the formula, and we obtain V equals pi over 12 H cubed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nilina Gira binti Azlan, matrix number AA251556. Okay, to continue from the previous explanation, I will now show you how we differentiate the volume equation with respect to time to find the rate at which the volume of water is changing. Previously, we obtained the equation V equals pi over 12 H cubed. Since both of the volume and water depth change over time, we differentiate the equation with respect to time. After differentiating, we get dV over dt equals pi over 4 H squared dH over dt. This equation shows the relationship between the rate of change of volume and the rate of change of water depth. Next, we substitute the given values into the equation. The water depth, which is H, is 4 meters, and the rate of change of water depth, dH over dt, is negative 0.2 meters per minute. Substituting these values, give dV over dt equals pi over 4 multiplied by 16 multiplied by negative 0.2. After simplifying, we obtain negative 0.85, which is approximately negative 2.5 cubic meters per minute. The negative sign indicates that the volume of water is decreasing because water is draining from this tank. Therefore, the volume of water decreases at the rate of approximately 2.51 cubic meters per minute, which means that approximately 2.51 cubic meters of water leave the tank every minute. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Nopana binti Azlan. My
My matrix number is 88251404. Today, we'll be, we'll be look at which cable potential optimization. When designing a subscription or cable storage, understanding the forces acting along the cables is absolutely critical for safety and efficiency. As we can see under step 1 on the slide, we are given a specific force function that models this behavior. Here, Fx represents the tension force in newtons, and X represents the position along the bridge or cable in meters. To find where this force reaches its absolute peak, we turn to the first derivative. Moving to step 2, we take the first derivative of our force function with respect to x. Using the power rule, the derivative of 200x is 200, and the derivative of negative 5x square root is negative 10x. This gives us our rate of change equation. Now, in step 3, we set this derivative equal to 0 to locate our stationary point by solving this simple algebraic equation, which is 200 minus 10x equals to 0. We subtract the 200 from both sides and divide by negative 10x, this which gives us the critical position of x equals to 20 meters. This is where our peak is hiding.
Hello, my name is Naifah Kazrina binti Muhammad Ridwan. My number matrix is 88251846. From section 5. So today I'm going to explain about 3.2 bridge potential optimization, focusing on the derivation, which is for the step 4 and step 5, which is second derivative test and maximum force. So for the step 4, second derivative test, we just do differentiate again, and we get f double prime s equal negative 10. Since it's less than 0, that confirm s equal 20 is a maximum, not a minimum. For the step 5, which is maximum force, we just plug s equal 20 into the original equation. 200 times 20 is 4000. 5 times 20 squared is 2000. 400 minus 200 give us 200 newtons. And if you look at the paragraph, the curve peaks right here at x equal 20. That's our maximum force. So our maximum force is 2000, and at x equal 20m, the negative second derivative confirm this is true maximum, not a minimum. That's it for me. Thank you.
Assalamualaikum. My name is Shafin Batrisha. My matrix number is AA251094. Now, let's wrap up our presentation with the conclusion. As shown in our findings, differentiation is highly essential for engineers to tackle real-world challenge. We focus on two main areas, which is the first one is related rates, where we related geometric dimensions using similar triangles to find that the water volume in the conical tank decreased at a rate of negative 2.51 cubic meter per minute. The second application is optimization. Here, we applied the second derivative test to find the stationary point, which confirmed that the maximum tension force on the bridge cable is 2000 Newton when x equal to 20 m. In short, these methods are crucial for any modern engineering practice to efficiently analyze data and optimize structural designs. Finally, here are the references that are specifically the textbook, Calculus, Siri Nota Kuliah Calculus by UTM. These are for foundational theories or differentiation and optimization. Second one is the Desmos graphing calculator, which is they help us to visualize the force function and verify our maximum point at x equal to 20. And lastly, our lecture note, which is DAT11203 lecture notes, which provide the core theoretical framework and context for both the conical tank and bridge cable problems. With that, we thank you for that.